So if the intensity of the incident beam is not changed, intensity of the incident beam will not change in that. With the following graphs best represent the variation of number with the frequency f of incident light. Say f naught represents the threshold frequency of the photosensitive material. Right. So intensity of the beam is not changed. So you know what intensity is? Intensity is energy per unit time per unit perpendicular area. So intensity is the number of photons, because you know in energy it's NHF. When it comes to energy, it's going to be NHF, right? So intensity is not going to change, because so the number of photons is not going to change. Number of photons is not going to change. So what is constant here? Number of photons per unit time. Right. So how do you find the answer here? So they want us to find number of electrons emitted per second. Number of electrons emitted per second. So when the frequency of the wave is less than the threshold frequency, there will be no electrons emitted. So definitely this one is wrong. Definitely that is wrong. There will be no electrons emitted when the frequency is less. And they say that now only one electron, only one photon can remove one electron. So when the frequency is greater than the threshold frequency, if 10 photons incident on this material, 10 electrons will be removed. If 100 photons incident on this material, definitely 100 will be removed. Right? So the capability of removing an electron comes after F naught. So every photon is now capable of removing an electron. So the number of photons which incident on the surface is also constant. So we can write that number of photons per unit time that is constant. So the number of electrons emitted per unit time, it's also constant. So that has to be the fourth one. After F naught, you can emit the same number of electrons for every frequency, because for every second it's the same number of electrons which incident on the surface. Surface electron. So it will be the same constant amount.